We're solving problem 13 from the Fall AMC 12A from 2021. The angled bisector of the acute angle formed at the origin by the graphs of the lines y equals x and y equals 3x has the equation y equals kx. What is k? So let's just draw this out. Here we have a graph. The x thing might be too long, so let's just attempt to redraw it. So here we can then represent the graphs. This one can be y equals x. This one is y equals 3x. And this one is y equals kx. There we have it. Now we can label these. And what we can do is use we can use an angle bisector here to get our values. So let's just see here. We have a couple of points which we can name. So let's just let this one be A, this one be C, this one be B, this one be O for origin. So let's make these values true, or not true. Let's just set the thing for these values. So we know that they have to have the same y. First of all, we know that O is at the origin, so 0, 0. So let's see, A is equal to 3, 3, and we set the y all equal to 3, as we want a multiple of 3 for the third equation. The y equals 3x. That's the simplest. C is equal to, C is equal to 3 over k, 3. I should put this b first, because it's pretty complex, but it'll seem more visually appealing. B is 1, 3, and C is equal to 3 over k, 3. These are all the points. So therefore, we can identify that we can sort of make these lengths across each other, sort of like a formula. So we can deduce that BC is 3 over k minus 1. CA is equal to 3 minus 3 over k. And these are simply these two distances. We have that. Now, by an angle bisector, we can figure out a ratio of terms. So we know that now OA, the ratio of OA over OB, is equal to the ratio of AC over BC. As this is an angle bisector where these two angles are equal. So we have that. Well, we can sort of plug in our values here, where this is just 3 root 2 over 10. And we can find that using the Pythagorean theorem here. The square root of 10 is equal to 3 minus 3 over k over 3k minus 1. Now, we can simplify this into 3 root 2 over 10. The square root of 10 is equal to 3k minus 3 over 3 minus k. Now, we can divide both likes by a same number here. We can get rid of the 3. So, this is just square root of 2 over 10, the square root of 10 equals k minus 1 over 3 minus k. Now, we can square both sides. So this simply gets us 1/5 is equal to k minus 1 squared over 3 minus k squared as an equation. So if we multiply this 5 over, and then this 3 minus k squared over, this equation still has the squares, but now becomes 5 times k minus 1 squared equals 3 minus k squared. And, well, you can just multiply these out, subtract the terms, and use the quadratic formula to solve for answer of k. That's pretty simplistic, where we get that k is equal to 1 plus or minus the square root of 5 over 2. Well, now, let's see here. We want k as, well, it can't be negative because the square root of 5 is greater than 1. So our answer for this problem is simply 1 plus the square root of 5 over 2. That's our value.